All right, boys and girls, welcome back to the drive-through, sponsored as always by the deli. Hungry? Stop by the deli. Get yourself a Jif peanut butter and jelly on wheat, maybe 2 of them or 3. All right, this is number 76 from 10.3. It's talking about a regular tetrahedron. How many faces does a tetrahedron have? 4, just like the Tetris shape, which is why it's called Tetris. It's a different prefix for 4. So in general, let's see. Does a tetrahedron have 4 faces?
6.
No, it's 4. Is this a tetrahedron? It's like a, yeah, that's a tetrahedron. Right? But why do I feel like it might be like this? All right, we'll graph one, and then we'll figure it out. So then it must be the first one. Okay, so it says, consider the regular tetrahedron with these points. So the points are 0, 0, 0, KK 0, so let's see. Okay. K0K. And 0KK. 0. And let's see, if we connected these, that'll give us, this would be what would be in the way, and then these would be dotted. So this probably gives you a better way to envision what you're looking at. It's just a regular triangular pyramid. Okay, so we sketched the graph. That's part A. Part B, find the length of each edge. The length of each edge. Well, so it's square root of k squared plus k squared plus 0 squared, no matter which one you choose, okay? So it's the square root of 2k squared, or it's k radical 2. So that's part B. Part C, find the angle. Okay, so find the angle between any 2 vectors. So let me name this as a vector right here, this pink one. So we would call that negative k, comma, k, comma 0. You could go the other way. It shouldn't matter. And then we'll call the green one k minus k, 0, k minus 0, k, and negative k. Okay, so the angle between the pink vector and the green vector would be cosine of theta is pink dot green. So 0 plus k squared plus 0, that's the dot product, over the magnitude, the product of the magnitudes, so k radical 2 times k radical 2. So you get cosine theta is k squared over k squared radical 4, so 2k squared. So, continuing on, k squareds cancel. Cosine of theta is 1/2 That makes this 60, right? So theta is 60, or pi over 3. Radians. That was part C. Now part D. Find the angle between the line segments from the centroid to two vertices. This is the bond angle for such a molecule like, what's CH4? Methane? Huge. And what's PbCl4? So lead chloride? Lead 4 chloride? Chemistry cheated way too much. It led to the demise of my life. I'll explain that story to you guys sometime. Okay, so we want to find the angle. Obviously, the chemistry doesn't matter for this problem, but the problem doesn't matter if you don't consider like why we're learning it. So the chemistry does matter, but it doesn't specifically matter for this math problem. Where is the point k over 2, k over 2, k over 2? It's somewhere like just hanging out right there. I'm just trying to get an idea. They want the angle between that and the line segments from the centroid to two vertices. I don't understand. Like, are they talking about this angle? This angle right there? Do you agree? Okay, so we got to come up with some vectors. So k minus k over 2 is k over 2. 0 minus k over 2 is a negative k over 2. And k minus k over 2 is k over 2. I can read that, so I'll clean it up here in a second. The other one I'll call a 0 minus k, well, 0 minus k over 2 is a negative k over 2. K minus k over 2 is k over 2. K minus k over 2 is k over 2. So what it's looking for is the angle between the vector k over 2, comma, negative k over 2, comma, k over 2, and the vector negative k over 2, comma, k over 2, comma, k over 2. Okay, so cosine of theta is going to be the dot product over the magnitude. So k squared over 4 plus a negative k squared over 4 I'm sorry, that's a negative too. This should be a negative right here, if you in it right. And then plus k squared over 4. So you just get k squared over 4 on the top. And then the magnitude of those will be the square root of k squared over 4 plus k squared over 4. So let's see. Which is the square root of 3k squared over 4. So that is radical 3 over 2 times k is the magnitude of each of those. So then on the bottom we'll have radical 3 over 2k times radical 3 over 2k. All right, moving down. So you end up on the top with negative k squared over 4. And on the bottom, you should have 3/4 k squared. And when dividing by a fraction, you multiply by the reciprocal. So cosine theta is negative k squared over 4 times 4 over 3k squared. Boom, boom. Oh gosh. Did we just get... Oh, no. We're good. So cosine theta is negative 1/3. And that's a calculator problem. What's cosine inverse of negative 1/3? 109.5. Is that what the back of the book had? Does anyone know? Or the calc chat? Or it's an even. But did we see that? No? All right, we'll look. Boom!